John's had an amazing career at OSU, and it's not over. I'm not trying to say it's over. No, yeah, he keeps threatening that. We don't listen to him. And, I was fortunate to also have John as a teacher when I was a graduate student, and John was an outstanding teacher. He's a committed teacher. He cares about his students. He cares about teaching the important things, the practical things. But John's also an amazing researcher. And one of the things that John's done is he's been a great collaborator with chemistry and physics and chemical engineering. So he has used these or taken advantage of these collaborations to do really revolutionary things. And he's going to talk about that, but we're really proud of the impact that he's had and what he's doing overall. John's also an IEEE fellow. He's very well known professionally around the world for the work that he's done. So I'll let him go ahead and talk about that. John.
Thanks, Terry. I don't know how I accomplished that being born in 1995, though. Okay. So what I want to talk about is some transparent transistor and related kinds of things. We invented the transparent transistor very late 2001. It was a group meeting right around Thanksgiving. It was reduced to practice over the Christmas break. Randy Hoffman, who's now at Hewlett-Packard, was the one who reduced that to practice. And this is one of the early pictures that we showed in 2003. Now, first thing about the Internet of Things for the educational or for the university people out there is first you patent, then you publish. I know the industrial guys understand that, but not all university guys do. So this was a picture that we sent into Science, and when the editor saw this, he said, "I don't see anything." And I said, "Well, that's the point. It's transparent." If you look carefully at it, the top 2/3 has integrated some circuits, very simple circuits, and there's an enhanced contrast image of some of the things that are there. So we invented a transparent transistor. We also identified what we hoped was going to be a killer app, and that killer app was a transistor for an active matrix application. Active matrix liquid crystal display at the time is what mainly we were focusing on. And that's not necessarily a transparent application, but if you had transparency, that might buy you a little, but it was other things actually. So we found the killer app, and then we got a lot of media attention on that for a couple reasons. Minority Report just came out, and so because of Minority Report, that's the Tom Cruise movie way back there, and there were transparent displays. I actually got quite a few calls from the military guys, captains. I don't think I had a general, but I had at least up to a major who said, "Okay, when we can buy these things?" And they invited me to give a talk at a military electronics thing, and they would ask me lots of questions, but they would never answer my questions in terms of what they wanted to do with it. But one of the other aspects of it is that it was zinc oxide. It's the stuff you put on your nose when you go to the beach, and so the media guys just had a field day with that. You can't see it, and you wear it. It's the stuff you go to the beach with. So we got a lot of media attention. We made the Wall Street Journal, had a nice talk with Ira Flato on Science Friday. We even made the Hindustan Times, which I'd never seen that before, and it was all kinds of media attention there. We wrote the first book on transparent electronics and came out in 2008. We wrote it about 2006. Then what we started doing is partnering with Hewlett-Packard, and we licensed that technology to them, and then we went into joint development. They were very interested at the time. They had a big project, very, very futuristic project. It's still futuristic, I'm afraid, but they wanted to do a lot of flexible electronic stuff. And there was some stuff going on at Palo Alto labs, HP labs in Palo Alto, that really coupled nicely with the kinds of things we were doing, and that was going on here in Corvallis at HP. And about 6 months after we had sub-licensed and started working on a joint development, then we invented the really good stuff, or we identified the really good stuff. Amorphous oxide semiconductors. Instead of using the zinc oxide, we used a new class of materials. These materials had been identified for other applications, but the transparent transistor, these kind of transistors hadn't been invented. So we identified this class of materials as really potentially useful. And when you design these, you go to this part of the periodic table, and you pick various cations. These are all cations, it turns out, from the periodic table, and you mix and match them. The one that really turned out to be the one that's making money is indium gallium zinc oxide, sometimes called IGZO. And again, you know, thinking about the Internet of Things, patent first, we did a lot of patenting, and usually our papers were about a year or two out after the patents. And then we went through about a 5-year period of fighting between what is the material, in this class of materials, these amorphous oxide semiconductors, which one is going to be the eventual victor. We were advocating at the time zinc tin oxide, zinc indium oxide, and I think those materials will be useful in future applications. But the current champion is the IGZO one, which, to be fair, was developed mainly by one of our competitors at the Tokyo Institute of Technology. However, because he's an academic, he wrote one patent. We at Oregon State wrote 6, 8, I don't know how many, and HP, they're usually 3 or 4 times ours. So we have a patent portfolio of about 40 to his one. And I think our patents are better written, too. So then, where did this take us? What's the enabling technology? The iMac I have on my desk now that came out in mid-October now has our technology in it. It has the IGZO TFTs. One story on that is the Retina display was supposed to have IGZO technology in it when it was first introduced, but they had some hiccups in transferring the technology into mass manufacturing, and so it was delayed about a year and a half. And so the very first iMac Retinas were not very good displays. In fact, the people reviewing just really slammed them. But if you read the recent reviews the last month or two, they really like this display. Sharp is one of the biggest electronics companies in all of Japan. Sharp is betting their entire career on IGZO, and they are hyping it. They even have an action figure, an IGZO action figure. Look this up. Just go to Sharp and look at IGZO, and oh, you know, it's very, very entertaining. But they're billing this like crazy. This is the first picture there is from the CES 2015, so it was last week. They hope to sell cell phones to everybody in China, which would be a pretty good business. One of the things about IGZO is you can turn it off better than you can the conventional technology that it replaces. And so they think there's going to be a lot of power savings in that. They just announced a product with Qualcomm MEMS tab. Apparently, you could drop that in your bathtub and it would still work. That's what they claim. It's not out yet. Dell, Compaq, all those guys, actually, they have options where you can buy these. There's a big 55-inch screen TV that LG is selling. Very, very expensive. It's got OLED technology, which is very expensive technology. And then the last couple of things, at the CES, this year there's more buzz on transparent displays. Looks like that may be the next wave, which since we wrote the first book on transparent electronics, we love it. And right now there's a big fight going on between IGZO and low temperature polysilicon. This was supposed to be the technology of the future, and it looks like we're displacing a significant fraction of the $120 billion a year industry. So we're pretty excited about that. That's all I have. Thanks a lot.